All right, terrific. Thank you very much. So at this point, we've set aside time for committee discussion with the various sponsors. And so what I would like to do is open up the floor to my colleagues on the committee who are here, and Lynn Ridderford, who's joining us remotely, if Lynn has any questions or comments she'd like to bring forward. So with that, let me open it up to members of the committee in terms of comments, questions for the sponsors.
Thank you all very much. The original discussion that we had in the formation of the committee included some comments about the tone of what was becoming the statement of task, or what we now have as the statement of task, that presumes that a certain level of development of gene drives technology is inevitable. Could you all comment about that? That it will happen.
Oh, press the button. Yeah.
Not the green one, but the one that says speak down at the bottom in smaller print.
Can you hear me? Okay. So I can say that we are funding a program in Gene Drive presently, and there have been publications recently on Gene Drive using CRISPR technology, and so it is something that's already in development, and so we can, that's why we've come to ask the committee to look at the work.
Yeah, and I would just add to that in terms of research on control of vector-borne diseases, the concept of gene drive has been talked about for probably 30 years at this point. And lots of different mechanisms have been proposed and tried already. Some of them have been shown to work in certain organisms, but not in vector mosquitoes. So it has been done already, for example, in Drosophila. And we know that the advent of the new technology is very exciting to the field, and we know that it has great potential to actually make this dream come to pass, if you will, in terms of vector biology. So yes, we're pretty certain it will happen.
And I also think it's hard to imagine, given the potential promise of the technology, setting aside the risks and concerns for a moment, and the parallel development, as we've heard already, of gene editing technology at a very rapid and ubiquitous now pace. It's hard to imagine a sudden stop in, just in a sort of what history has taught us about the way emerging technologies develop over time. So it's hard to imagine that you won't have some continued evolution in this arena.
All right, Phil?
I would also just say that each case of application, each experiment is different, and should be evaluated on its specificity. And so having a set of principles by which the community can apply that will be important. But every single application will have a different risk and a different benefit.
But if I could, just to put a fine point on Dr. Heitman's question, you're seeing an inevitability of the maturation of this technology going forward, is what I'm hearing from this group. All right, thank you. Let's go to Dr. Landis, and then I'll go to you, Vicki. Chandler.
All right. So I've heard there's lots of uncertainty. As a risk assessor, uncertainty to me is like snow is to the Inuit. Okay, there's lots of different kinds, but the only kind I really heard from you is a lack of knowledge, not variability and all those kinds of things. Is that what you're basically saying, is you have a lack of knowledge about what will happen with the introduction of gene drives? Or is there something larger than that? I'm speaking especially to the first speaker because you used uncertainty several times in a row.
I don't think it's just about uncertainty.
Or lack of knowledge.
Or lack of knowledge.
All
Yeah,
right.
I don't think uncertainty is just lack of knowledge.
It's not.
Yeah, so, you know, so we spend a lot of time, I spend a lot of time in looking at other dual-use technologies too, in which we have a tremendous amount of knowledge, and there's still a lot of uncertainty. I think that's probably always going to be the case in you know, some areas of science where you're trying to assess risk.
Well, actually, we have uncertainty all the time and we quantify it. So I'm just trying to narrow down exactly what you're talking about. My second question is, only DARPA talked about ecological because of the threat. And of course, part of that is because the reason you would go after a fishery or something like that is because it is affecting human welfare in a very broad sense. Now, the rest of the speakers really talked about human welfare as opposed to just human health. I'd like to have some feedback on how important human welfare in a more general context is, because human health could be an aspect, but human welfare incorporates recreation, fisheries, lots of other things. And I only heard that from one of the presenters, so I'd like to have some more input into that.
And apologies, maybe I was talking too fast to get to my 1 minute limit, because we care quite deeply about that as well, both in terms of human populations as well as non-human populations, their place in the ecological spectrum as well.
Yeah, I think perhaps the reason we didn't touch on it specifically is that obviously those considerations are very specific to a particular type of technology in the context of where it will be used. Certainly in the course of the research that we support, we are doing extensive risk assessments for every stage of the research, and those include potential for ecological risk, potential for increased transmission of other diseases, potential for some adverse effect on the community. We're very concerned about all of those issues as we look at the application that we're working on.
And can you give me the citations for those assessments? I shouldn't say me, the committee. I'm sorry. I'm the risk assessor, so I tend to focus on that.
So there has been a risk assessment just done on the first stage of the technology that we're involved in, which is not a gene drive stage. It's just been done by the CSIRO biosafety group in Australia. It is just nearing completion, and it will be published on the website of the project shortly.
Great, thank you. We can follow up and get that citation also, as far as that's concerned. Dr. Chandler.
Yes, well, thank you all for funding this committee's work. It's very important, and I appreciate it. My question had to do with the scope of the statement of task, in that it explicitly says non-human organisms, which is pretty broad, and with the exception of the DARPA representatives, the focus has really been on a lot on vector-borne diseases. So I guess I would just like a perspective from your part on sort of prioritization, or, because as someone said, they're going to be very different situations for potentially, forests and plants versus insects versus different kinds of animals. So I would just like some additional information on your thinking on scope.
We think that the vector-borne diseases topic is is likely to be something that will yield a lot of information to the committee because it is rather advanced, relatively advanced, as opposed to some of the other potential applications. But we would prefer that the panel didn't focus entirely on that because we think that this new technology will be applied broadly. And so we'd like to see that the recommendations, the guidance that you come out with would be relevant across the entire spectrum of this potential research.
And we look at health very broadly, so it's not just about infectious disease, it's about food production and sustainability, which may go sort of outside the sphere of vector-borne illness in terms of applications related to human health.
Let's go to Dr. Tate. Oh, the same question. All right. Then Dr. Higgs.
I just wondered if the sponsors are currently supporting and financing this type of research involved, say, with CRISPR, and how you are currently evaluating whether it's responsible and ethical or not.
So we do support research using CRISPR. In fact, we were involved in supporting the Drosophila study that was published in Science and garnered a lot of attention. And certainly we support a lot of a fair amount of gene editing research in very basic fashion across the board. So yes is the sort of simple answer to the first part of your question. And we don't currently have a sort of special ethical sort of consideration beyond the current oversight systems that are in place. So, oversight of recombinant DNA, for example, or, if they're involving humans, through the IRB system. So, but it'll be interesting to hear the committee's thoughts in that regard.
Go ahead, Greg.
Yeah, if I would like to just come back very sort of loop around to the question that Liz and Jim put on the table at the very beginning about the progress of the field. You agreed that the research is going forward. There's also a question when we look at the scope about the applications themselves, whether and how they go forward. Phil, you said that there should be a case-by-case analysis of the risks and benefits. So a follow-on question from the question of whether the research goes forward is whether any given application has to go forward just in the safest way possible, or whether it might be that on the basis of a risk, a cost-benefit analysis, that, maybe you'd have to step away from an application. I'm just curious about your views.
Yeah, I mean, that's true. So nothing goes forward unless it clears the hurdles. And so I think the investigators that we sponsor, and I think anyone in the scientific community would not want to move forward with something if it was deemed inappropriate.
Would that be true across the board? I mean, you would all sort of support that position as far as the use of the technology is concerned. All right, Dr. Delborn.
Thank you. A number of you mentioned issues of oversight and responsible conduct, and I just wondered if you were thinking about issues of governance in terms of intellectual property and issues of responsibility post-release, or if you were thinking that the scope of the committee would focus more on traditional regulation, responsible conduct, and oversight.
I would say both. I mean, I think given, there's I think certainly consideration of the current framework and how that might be reutilized or expanded is important, but also given some of the innovative applications that are proposed for use of gene drives that may require some innovative thinking about sort of oversight and regulation going forward. When
we worked on the WHO guidance framework for testing genetically modified mosquitoes, we certainly included thoughts about how phase 4 post-implementation surveillance activities and potential for mitigation of unforeseen risks would need to be considered. So yes, in that aspect, personally right now, I think we really need guidance on the development pathway all the way through to field releases, but that would not abrogate the need for thoughts about how to deal with the technology beyond that.
Dr. Winikoff.
Again, thank you so much for coming and supporting this work. I'm interested in maybe getting a few of your own thoughts coming into the process or as you pass it to us, a little bit more specific about where you think there are potentially gaps. Could you kind of talk about areas that you think are currently need to be reviewed or aren't captured by, let's say, the existing GMO regime and regulatory system? What in particular, if it's important to do this analysis, there must be a sense that there may be some gaps. So what are they?
So I would say that at least my concern is when if there, with CRISPR technology being now readily available and having spent time in the laboratory, there's a lot of creativity in laboratories around the world. There's a lot of tools and flexibility, and so it's very easy to just set off and do an experiment without really knowing all the consequences. And even if one went to an institutional safety board, if the institutional safety board didn't have all the information, they may not be able to make an informed decision on how that work should be carried out. And so it's a matter of really putting some visibility and some around what a graduate student or a postdoc would need to know, what a PI would need to know on whether or not to move forward with even a particular experiment, whether they even have the facilities to carry it out, whether they have standard operating procedures and levels of safety on how to do that, how they would even assess the risk. I mean, these are complex issues, and again, if you can just do an experiment in the lab and not know that this entire sort of process, this way of thinking, needs to be incorporated before one even starts an experiment, then that becomes problematic, because then that's where someone might do an experiment not knowing that the trait will escape from the lab. And so I think it's just important, particularly when a field is so exciting and new, and folks around the world are all applying CRISPRs for all types of applications, not for gene drive. There's a drive for publication, and all of that. And so I think just having sort of a way to soberly analyze an experiment before it's done, or a program before it's done, I think is really important.
I think, and this is not limited to gene drives per se, but when you talk about emerging technologies where the sort of proposed applications are by their nature very global or international in nature, thinking about oversight and regulation, or even having the conversation of these sort of multifaceted potential promises and concerns becomes much more difficult. I mean, the truth is we just don't have as many sort of international policy vehicles as we would like in some ways to think about, to oversee, to regulates, although I'm a little hesitant to use those words, things that are very global in nature when it comes to technologies. And so, I think we're very much seeing that come up in the context of gene editing and other applications like germline modification, for example. How do we talk about these things? We know where we stand in the oversight system we have in place in the US, but then when you start talking about more global applications of these technologies, the conversation becomes a lot more difficult. And with gene drives in particular, because of a lot of the applications, as we've mentioned before, are inherently international, there are more gaps in terms of our ability to discuss and implement oversight.
Dr. Kingiri.
Thank you so much for your presentations. My question goes to Phil. Do you think eradication or elimination of malaria as the main motivation for this kind of research? Because you really concentrated on malaria as really the driving factor behind, funding this kind of research. And to me, I would want to hear from you whether there are other factors which could play out in terms of implementation of the recommendations which are going to be coming out of this committee, issues of regulatory capacity, implementation of this kind of recommendations, governance issues, politics, poverty issues, this complexity, complex issues which are really affecting what we are seeing happening in sub-Saharan Africa and Africa. Really, don't you think some of these factors should also be looked into from a system or holistic perspective, in your view?
I'll completely agree. And so our funding, because the malaria application is so important, is focused on that. So gene drives can be applied for other problems in Africa and elsewhere around the world. But that's not, at the moment, that's not what our focus is. It's on malaria. So that's why I spoke to malaria and that particular application. From I think from a perspective of capacity building and governance, political will, buy-in from the communities, the governments that would take this on in Africa is top of our mind. And so we in some of our funding there is capacity building. It's been baked into the program from the very beginning. We completely believe that that without the parallel building of capacity in places where the technology will be deployed is absolutely necessary and is being funded as such.
No. Okay, good. A quick question, to go back to Dr. Chandler's point, so your statement is of task is quite broad. I mean, it's a big remit. Is there any guidance you want to give us relative to how you're thinking about potentially interacting with other agencies? I mean, you're all representatives of particular agencies here, but have you thought much about interacting with other agencies around this set of issues, either national or international? And is there any guidance you want to give the committee in terms of how we might think about that issue from your point of view?
When we had original discussions about supporting this study, we did have discussions with representatives from some of the U.S. regulatory agencies, and I think they were very interested in providing input and thoughts to the committee. I think it's certainly would be useful to look beyond the U.S. regulatory system for some of the potential applications.
Thank you. That's very helpful. Other comments?
I would say that, speaking from wearing my hats as the sort of overseers of the NIH guidelines, we clearly in so much as we're involved in that space, spend a lot of time talking to sister agencies like the FDA, of course. You know, the guidelines don't allow for field release because they only address sort of research under containments, but there is the ability to have another agency approve research, in which case, if there's relevant regulatory authority in place, we wouldn't have a role. And you can imagine the USDA, for example, is an agency in which we often have that sort of interaction. So those are just two within that space that we frequently engage with.
So it would be fair to say you'd like us to think fairly broadly, both within the U.S. as far as other agencies are concerned and even internationally?
Yes.
I think given the technology, the capability, the facility of this technology, and the presumption that's been made for the formation of this talk, and then even up here on this thing, that there's consensus that this technology is going to happen and be applied. If it's going to be applied, then I think we need to ensure that there is at least a regulatory path that is clear and a strategy to pursue it. Because if there is not, then it will happen without that type of guidance and oversight somewhere in the world. So I think it is hopeful that there is a path for the appropriate use of this type of technology should it meet certain capabilities and caveats that are going to be, of course, there. But there is some path. Because right now, for example, even on vector control, is it USAID, is it EPA, is it FDA? Who has governance? Who is shaping this? And if it becomes Byzantine, the technology will be taken elsewhere, and there may be no regulation of it. So that is absolutely, I think, an important concern as an individual. Now, I believe, speaking from DARPA, we're a little bit tabula rasa on policy and rules. There are rules and tools, and hopefully there will be rules, and that's the purpose of this committee, and whether those rules are at a very stringent level or whether their policies and recommendation is of you to guide us. But on tools, I think there's an ask here, and it's a very specific ask. What are the tools that we need to use to have a capable gene drive, because it inevitably is going to be used, and if there are clear recommendations on what those tools are, then we can collapse some of the potential vectors of this vector control technology down to ones that maybe have a path towards success. And that needs clarity. Without that clarity, then it is the Wild West of technology development.
Very helpful. Phil, did you want to?
Yeah, I also just wanted to say, this is a U.S.-based committee, and I just want to make sure that there's consideration to the thinking, the sovereignty, and the needs of the developing world as well. So one sits in the shoes, and that countries, say in Africa, that have a say in what technologies and capacities that they can build, and that there is a sense that that this is not just a U.S.-centric thinking, and that the guidelines are general principles, but in the end, I think countries will make their own decisions on what to do, and so this this panel can provide very important guidance on how decisions can be made, but the decisions are made by sovereign governments and people.
Thanks, very helpful. So we're going to give the last question to Dr. Tannehill and wrap up this part of the session.
Thank you again for your presentations. I just wanted some clarification. The DARPA rep mentioned something about looking at the best, or referred to looking at different emerging technologies, different types of genome editing techniques. And I wanted to know, is the expectation that we will look at these different applications and then provide suggestions as to which specific technologies would be best utilized for those?
I think that would be a Herculean task. I think if you could have guiding principles on the types of elements that you would want of this containment, on safety measures, on what would a good gene drive technology general principles around it look like? And what would be one that you would be concerned about? And what is the path to be able to use it in a safe and effective way? I think would be very helpful.
And just to continue on that thought, think about, put yourself in the shoes of a postdoc who has an idea. And then we've all been there. Exciting, you think you're going to go and, do something incredible and publish in Nature or Science and do great things after that. And so, when that idea is first emerges, put yourself in that postdoc shoes and go, and say, what would they actually, what's the next step? What would I do? What do I need to know? How can you keep me from tripping over myself? And so I think that's probably, that would be the way I would approach this, is start from the beginning and move out from there.
I think the idea that we had initially was simply that you would use case studies that might be based on particular applications and presumably particular applications that would be used under different conditions. And that would simplify your task of looking at what the current regulations and guidance is. And then based on that, you could perhaps make more general recommendations.
And recognizing that science is a moving target, and if it was easy to see the pathway of technology development, we would all be rich, right? I would say I think it would be very useful, in answer to your question, given all of the sort of excitement and hype and buzz around both gene editing technologies more generally and gene drives in particular, a very clear assessment of what the state of the science is, the effectiveness of these technologies when it comes to target and non-target effects, the feasibility going forward of refinement, and looking at that in sort of the spectrum of potential applications would be very helpful, because I think it's a little bit of a murky area just because there's so much chatter about it.
All right, terrific. Thanks very much to the study sponsor representatives. Your answers have been really very helpful to the committee. So thanks for taking the time for being here. Thanks for all of your intellectual input and support up to this point. Fran?
They're welcome to stay and hear the presentations if they want.